Good morning, ladies and gentlemen. This is the Lightweighting Your Designs Using Solid Thinking Inspire webinar. Now we're going to go ahead and get started. Basically, I'll start off by introducing you to Boundary Systems, who we are and what we do. And then next up, I'll share some success stories. Good morning, ladies and gentlemen. Welcome to the Lightweighting Your Designs Using Solid Thinking Inspire webinar. First off, when we get started with this here, I will introduce you to the, company. I'll tell a little bit about myself and Boundary Systems, who we are and what we do, although some of you are familiar with us. And then next, I'll describe in more detail what Inspire does. And I'll mention some success stories about companies that are currently using this and what it's done for them. And then I'll show you a quick demo of the software, and then after that we'll open it up for questions. Okay, so just a quick note here about Boundary Systems. So we are a leading technology provider of product design and consulting services in the Northeast Ohio area. And also basically in the general Midwest region. We also have customers in Michigan and also in Canada as well. And we do everything from CAD data management to design and consulting, computer simulations, which this falls under, and also we resell for the largest 3D printing company in the world. And so from just a few of those pictures over there, you can get a sense of the big name companies that we've worked with. And also we have made the Inc. 5000 list, which is basically a list of the 5,000 fastest growing companies in North America. We've made that now for the last 4 years in a row. And so we do a pretty good job of holding our own weight in our industry. And this is just some information about who I am. My name is Shaish Mbore. I graduated from Vanderbilt and Case Western a few years ago, and I studied mechanical engineering, and I got a master's. And after that, I started here at Boundary, primarily focusing on simulation products. And so everything that deals with computer simulations goes through me, and I have a lot of fun with that. I also do some training and consulting on the simulation products or on other Creo parametric or products as well. Now, on to Inspire. So first off, what does Inspire do? So Inspire is a geometry optimization software that basically creates structurally efficient concepts. And so, just as you can see in this screenshot over here, if you can give Inspire a spot where you know that your loads are going to come from, and you could also then tell Inspire where the constraints are going to be, so where the load is going to end up passing through, Inspire will generate in between that the most efficient structure to transfer the load from the application point to the constraint locations. And so because of that, it basically solves challenging design problems pretty easily, because it can show you up front the most efficient way to do what you're trying to do. And not only that, but the standard runtime of Inspire is about 20 minutes on a typical laptop. And so it's very quick and easy in that. I mean, in 20 minutes you can understand how your load prefers to be passed, and you can then design something that would fit that. Now with Inspire, basically the three main things are that it's faster, smarter, and lighter. So first off, Inspire runs very quickly, and so that way you can get it right the first time. And as a result of being able to get it right the first time, whenever you run an optimization with Inspire, you can get the design input up front in the design process, and so that way, instead of having to be many iterations down in the design process and then the FEA guys mentioned that your design, will fail. As a design engineer, which this product is built for, if you can, start your design, understand how your loads are going to be transferred, and then build something that fits that, it makes it, a much better candidate for that design, passing through without having as many iterations as you typically would have. Not only that, but you can design smarter. You can basically understand your loading and geometry, and so that can then, help you understand more options that can be available to you regarding, swapping out materials even, or even changing the way you're designing your model in order to achieve more stiff models. And then finally, and sort of the holy grail, is that you can also reduce your part costs because Inspire can show you the most efficient way to transfer that load. All of a sudden, any area where you don't need material, Inspire highlights that for you, and so that's basically saving dollars and cents in your pocket. And now just to transition here into some quick success stories about companies that have used Inspire so far. This Inspire application here was by the Liebherr Group in Poland, and this component here goes at the bottom, on the bottom of a tractor-trailer axle. Now, this one component here weighs about 8 kilograms, and I don't know, this design has been a legacy design. It's been there for many years, and everyone else kept using it because the guy before them used that one, and the guy before them used that one, and whoever started that design just thought that was the best way to design it, and so everyone else used it. Well, they were able to put that into Inspire and say, hold on, can Inspire generate a better mousetrap, to use an analogy? And Inspire then goes ahead and spits out the result in the middle over here to show them that, okay, you know what, you can make some pretty huge pockets in here and still be able to support the material that the loads that you're trying to transfer. And based on this Inspire design optimization proposal, they were then able to create their final design on the bottom right corner over here, saving 55% mass, and they were still able to transfer the loads that they were designing this model to transfer. And so basically, now they cut the weight down to about 4 kilograms, and they were still able to transfer that load. Now, just to give you an example, this one component is used 6 times on a tractor trailer. And so all of a sudden that 4 kilogram mass savings translates to at least 24 kilograms across the entire system. And so that can give you an idea of how powerful Inspire is used, or Inspire can be when used across the entire system. Next up here is talking about Polaris. They make snowmobiles. And for them, one of the things that they wanted to do was to, primarily reduce the weight and, not compromise the structural integrity. And with Inspire, what they basically found was Inspire was able to generate new geometry shapes for them that they did not consider beforehand. And with that new geometry, they then realized that the stresses they were seeing were so low that they could swap out steel, which they were currently using, for aluminum and not compromise the performance. And as we all know, aluminum is much lighter than steel, and so they basically did a material swap and were able to come out with saving about 30 to 40% of the weight without compromising performance. And the other thing it did for them is that because they're design engineers on the front end were able to use Inspire, instead of their typical 10 to 12 iterations where the design engineers would build something and then send it to the finite element analysis analysts to analyze, and then do that 10 to 12 times before deciding on a good design, that cut it in half. They only needed about 5 to 6 iterations between them. And that again translates to cost savings because you can get to market faster. You don't have to build as many prototypes, and you can save engineering hours that way. Now the previous 2 designs have been focusing more on, I guess, big solid metal parts. In this case, this is more of a plastic application. Evenflow, it's a world-leading child product safety manufacturer. And in this case, they were using Inspire to optimize a car seat component. And for this particular case here, you'll notice that Inspire generates, pretty nice looking geometry that you can, eventually mold out, using injection molding techniques, and it looks aesthetically pleasing, as whenever you put it into a physical, product. And they were able to do this using 25% less material than the original, and yet still hit their design targets. And so that just gives you an idea of companies that are using Inspire and some of the benefits they're getting out of it. Now I will I'll pause here for a second and bring out the software and show a quick demo. And so I'll pause the PowerPoint here and see here. Okay, so whenever you open Inspire, this is a typical window you're going to see. So it's just typically a blank screen. And now what I'll show is how you can basically start using Inspire here. So in this case, I'm taking a Parasolid file and importing it into Inspire. And with just a drag and drop technique, you can basically import everything in. Which is another thing about Inspire is because of how it's built, Inspire is basically CAD agnostic. So regardless of what CAD package you have, Creo Parametric, SolidWorks, Inventor, whatever the CAD package is, as long as you can generate geometry and create geometry files from that, you can use Inspire. So Inspire can read in, Creo files, ProEngineer files, SolidWorks, or even neutral formats like the Parasolid I just imported in, or even STEP or IGES files. And so that way it's CAD agnostic, and you can very easily use it regardless of what package you're on. Now in this case, this is a sub-assembly of a bicycle. So just if you can imagine here, this component over here goes up to the handlebars. This component over here is where the front wheel fits into, and then this component over here, I believe, goes on to where it holds the seat, and then all the way back to the rear tire. And now, what we're interested in redesigning in this case is this middle component right here. And now with Inspire, it's very easy to start simplifying, the model and to start generating a redesign. And so all I'll just do is configure this here and say, I don't need that component, I don't need this one, I don't need that one as well, and neither do I need these other two. And with just a few mouse clicks, I've been able to isolate the one component that I am really interested in optimizing. Now, the other thing about Inspire is that Inspire has some pretty quick and easy geometry manipulation tools as well. And so with this here, if I was going to get rid of these pockets, because it looks like the previous designer, whoever it was, started designing this, and he had an idea of using some pockets, but it seems like I don't know, he didn't know where to place those pockets well, or Inspire may have better recommendations as to where to place those ribs and the pockets in there. And so what we'll do in this case is instead of taking that engineer's design, I'll go ahead and remove those pockets, because with Inspire you want to give it as much space, as much empty space as possible to play with. You don't want to have as much detail in there, so that way Inspire can fill in the details itself. And so we'll go ahead here and quickly simplify this and say, okay, let's identify any holes in the model. And so basically all these pockets you see over here, and I can just click on that, and boom, that's removed. Can pick on this over here as well, and that gets removed, and likewise on the other end as well. And then I can then go ahead and do the same on the other side as well, and just picking on those different highlighted areas, and all those get removed. And you'll notice with just a few mouse clicks, I'm able to get rid of all that detailed geometry that I want to get rid of, and have give Inspire as blank of a slate as possible in order for it to fill in with my design. Now I'm going to swap this out here for a model that's already been fully set up with the loads and constraints. And basically the only difference between those models is this purple region right here has been specified as a design space. And so that's basically the area that Inspire can modify or tweak. That's the area that's like Play-Doh to Inspire, where it can, change the shape however it wants. Next up is we have the constraints and loads already defined in this case. And the beautiful thing again about Inspire is that for your loads and constraints, Inspire can support multiple load cases. And so sometimes, the person's going to be, sitting down vertically on the bicycle, and so you'll have a certain set of loads. And then at other times, the person could be, going down an incline, and then the orientation of those loads will change, and so you can have a different set of loads. And Inspire can optimize multiple load sets together, during an analysis. Now, in this case, let's see. So we currently have everything we need, and when we're defining an Inspire design, there are a couple different ways to run it. One way is to give it a certain percent of the volume and have it to give you the stiffest possible shape. And so with this now, whenever we run this, and now what I'm basically going to show here, this is one of those, whenever you watch a cooking show, they basically show you how they cook something, and then they put it in the oven, and they whip out an already prepared version out of the oven to show you how it's eventually going to look like at the end. And so this is a case where I'm going to whip out, an already prepared simulation here, where Inspire then generates, okay, using 30% of the existing material in that purple space, this is the stiffest way you can arrange that material in order to bear the load that you want to bear. And you'll notice Inspire efficiently shows you where you can get rid of the material, and instead of making webs, you can create entire holes in there and get rid of all that material because you don't need it. Now, in this example here, this is using 30% of the material. There's really no guarantee in this case that that 30% will be enough to support the load. Inspire just gives you the stiffest thing you can find with the material percentage you've given it. There is another way to run the optimization though, and that is using the safety factor method. And basically with that, instead of asking Inspire for given a percentage, you can change that and say let's specify based on a safety factor. And so given the material I have in there, say for example steel, I can say if I want to meet a safety factor of 1.2, run the analysis and generate for me the shape that meets that safety factor using the least amount of material. And so in this case, when you run the analysis and I take a look at the results here, this pops out being the most efficient shape to meet that load. And now I can basically see how I have similar ribbon structures around this area. And I can see over here, it got rid of one of those ribs from the 30% case. And so basically I can even use less material and still achieve my design goals. Now, I should also mention that even though we're showing you already, run analyses in this case, each of these Inspire analyses only takes about 15 to 20 minutes on a standard laptop, and so this isn't something that you set to cook for days before coming back to a result. It's something where you can basically run multiple quick analyses, and then from that design insight, be able to start designing your model. And so the other thing I was going to show about Inspire is the fact that after running the optimization and you're satisfied with the geometry you get, you can then run a fit command, which basically will generate smooth CAD surfaces that you can then take as it is right now and export this as an IGES or as a step file into your preferred CAD package, so SolidWorks or Creo Parametric or ProEngine, things like that. You can export this back into that and then start building your design off of what you have in here. And then whenever you have that design fully built, it'll then basically be able to perform the same way that the Inspire model here performed. And so in this case, I'll hide this suggestion here and highlight over here the fully detailed design that was built off of that Inspire proposal. And you'll notice how much lighter it looks when it comes to the different holes and pockets that were able to be added in this case. And so that shows you a quick example of how to use Inspire within the design process for your typical design engineer. So you basically start from what you know regarding the loads, tell Inspire where to remove material, and then based on that you can then start building your design to meet that criteria. Now we'll get back to this here. So just to sort of wrap up as a summary, Inspire is built primarily for design engineers, and because you can use it as an upfront design tool, you can basically get it right the first time, because you no longer need to have as many iterations in the CAD or FE loop, because you can start with a very, very feasible model that will survive the wait. And not only that, but you can also then reduce your material and part costs, because Inspire can show you the lightest way to transfer a load from one particular area to another. Next up in here, if you need any more information about Inspire, what it is and what it does, or any sales questions regarding the pricing and things like that, you can buy. This is my contact information and also that of our sales manager. You can contact either one of us, and we'll be glad to answer any questions you have, either on the technical end or the sales end of things. Thank you very much, and this is the end of the webinar.